Hello and welcome to the Semiconductor Industry Association public webinar series where we discuss issues impacting the semiconductor industry. My name is Robert Casanova. I'm the Director of Industry Statistics and Economic Policy here at SIA, and I will be your moderator and host for today's webinar where we discuss semiconductor design and its importance to the greater semiconductor ecosystem. Today's webinar, we will be discussing the recently released SIA and Boston Consulting Group report on semiconductor design titled The Global Challenge of Semiconductor Design Leadership. And I am happy to announce our panelists today of experts to discuss this issue. Our first panelist is Ramiro Palmer. He is the managing director and partner at the Boston Consulting Group, and he was a lead author on this SIA BCD report. Following Ramiro is Kevin O'Buckley. He is the senior vice president of Marvell, and he is the managing or general manager of Marvell's ASIC business. And finally, we have Mark Fusilier, who is the Senior Vice President of Technology and Product Engineering at AMD. As I said, SIA's recently released report on semiconductor design is a important report highlighting the importance of design to the semiconductor ecosystem as a whole, but also its importance to manufacturing and OEM. And to start off the discussion on the report, I'll pass it over to Ramiro.
Thanks so much, Robert. Let me quickly pull up the pages. So appreciate everyone's time, as well as the partnership from both the SIA as well as all of the member companies as we've pulled this report together. Just as a quick reminder, this is the fourth in a series of reports covering a variety of critical topics in the semiconductor industry. So very excited to share the discussion today related to design. The goals or the objectives of the paper, there were, I think, three key things. The first thing we were looking to do is provide an overview of semiconductor design, as well as the benefits of leadership in design. We then wanted to discuss the key risks and challenges to maintaining design leadership and outline at a very high level some of the policy directions or actions that could be taken to address those challenges. Just for definitional purposes to start, or for context, semiconductor design consists of four major steps. There's the initial upfront product definition, architecture, and system design, where we kind of get into the block level design of individual products, IC design and verification, and then finally post-silicon validation. So just to give a little bit of flavor for the kinds of things that are happening here. The US is the longstanding global leader when it comes to semiconductor design. So on this chart, you see for different kinds of chips, as well as for EDA and core IP, which are enablers of all design activities, the relative distribution of revenue share by region, for logic at the top, memory and discrete, analog and other, and then EDA core IP at the bottom. You can see that for logic, the US has 64% of total global share. 28% of all industry value add comes from logic design, and the R&D intensity, so effectively the percent of revenue that needs to be spent on R&D in this area is about 20%. If you look in aggregate across all of the different chip types, the overall value add is about half. About half of all value add in the industry comes from design activities, and the R&D intensity is quite high. It's 17%. You can see that the US has about 46% of global share for design, and on the bottom, EDA and core IP, the US also has a leading share, 72%. Smaller industry value add here just because of the relative size of the EDA industry, not in any way commentary on the criticality of EDA, and the R&D intensity for EDA, of course, is much higher even than for design itself. So the leadership that the US has really confers a number of benefits, and here we've summarized some of the top ones. The first point is is really a virtuous cycle of innovation. Leadership allows companies to attract global talent. It allows companies to reinvest at the levels that are required. We talked about the intensity of R&D, associated with design. It creates the ability to shape standards, whether it's in Wi-Fi or other standards and protocols, which naturally confer benefits to the companies who are able to do that. Creates a stronger, kind of security footprint from a national security perspective. Having a high presence of or high availability of domestic made chips lowers the risk of supply disruption. High quality employment, the jobs pay quite well in the design space, and there's significant benefits for OEMs who are able to closely collaborate with local design teams. So significant benefits, again, associated with the leadership and design. But leadership is not a static construct. So this chart shows, just to illustrate that, the top 10 semiconductor players by decade, with the country coding, yellow for Japan, dark navy for US, and you can see the other colors, the legends in the lower right. The key point, I think, from this page is, over time, the mix of companies and market share and leadership can really change pretty dramatically. Starting with the 90s, you can see here a heavy presence of Japanese companies, to now 2020, largely filled, the top players largely coming from the US. So there is risk of, at any point in time that things can change and that the US could potentially lose its leadership position. And as we look at the three key challenges facing the design industry as a whole, as well as the US as it looks to maintain design leadership, the first is really design costs. Design costs are rising dramatically for both fundamental and technical reasons. The next challenge, which we'll talk a little bit about, is the workforce, which is expected to be significantly undersupplied in the US by 2030. And finally, as we talked about earlier, the R&D intensity means that design companies need scale. They need access to global markets. And as we see trade tensions or trade dynamics evolving, this is something where we can't simply take for granted that markets will be open on a go-forward basis. So just very quickly, likely familiar to many folks on the call, design costs go up with each new technology node. You can see here 65 nanometer nodes, when they were introduced in 2006, a new SoC design cost about $30 million. Today, estimates for a 5 nanometer chip are more than 500 million, so an 18x increase in the cost to design a new chip. And as you look at different countries, the way they fund this design, the share of semiconductor specific design R&D funded by the private sector is greater in the US than in other OECD countries. So US companies, US design firms, bear a higher proportion of this growing cost than some, for example, companies in other regions potentially. Here, you see kind of for each country on this chart, you see the total amount of design-related R&D is the size of the bubble, and then the distribution between private sector, direct public R&D fundings. This would be things like NSF research or other public academic research, tax incentives, and then other kind of more recent programs are kind of broken out here. You can see the US, about 87% of design-related funding is coming from the private sector. So it's a very large proportion. The US design workforce, moving on to the next point. Today, there's about 66,000, or excuse me, by 2030, there will be a need for around 90,000 folks to work in the design industry based on projections in terms of market growth if the US is to maintain its current leadership position. But the total size of the design workforce that we've modeled out based on matriculation, immigration patterns, retention patterns, et cetera, is going to be only 66,000. So there's a pretty big gap, about 23,000 engineers, which is about 35% of the total requirement for 2030 demand. So that is something that will need to be addressed within the US, is this workforce shortfall. And then the last point, just to illustrate this a little bit, the importance of open markets. The US OEMs have the greatest demand for semiconductors, so the US is a great market for design companies, but it's a little bit more than a third of total semiconductor demand. Look at the OEM level. So there is a need to ensure, or rather there is maintaining scale, requires access to other markets in other regions in Asia and in Europe and the rest of the world. So in the absence of action, one thing that we do in the report is we model out, what does market share for US design companies, which is a proxy we're taking for design leadership, look like over time. And under the current trajectory, we're forecasting a decline from about 46% in 2020 to about 36% by 2030. So significant decline there if kind of some of these actions related to workforce, related to R&D, and related to open markets are not addressed. So, what does that mean from a policy perspective? Obviously, focusing on public support for R&D, workforce development efforts as it pertains to design, and ensuring open access to global markets are going to be critical on a go-forward basis for the US to maintain design leadership. The size of the prize here laid out in terms of market share, dollars, and jobs. Over 10 years, if the US is able to maintain its current level of design leadership, we've kind of estimated an additional $450 billion of incremental sales versus the trajectory we showed on the previous page, as well as 150,000 new jobs, both direct and indirect jobs. So with that, that concludes the prepared slides. I see we've got a couple of questions that have come in. Robert, I'll let you MC.
Thank you, Ramiro. Just as a housekeeping before I pass it along to Kevin, as I see some have already asked their questions in the Q&A tab, but again, please make sure to ask your questions in the Q&A tab and not in the chat. And also, one more point before I pass it to Kevin, and I must acknowledge, originally we had Susie Armstrong, Senior Vice President of Engineering, as a participant for this webinar. Unfortunately, due to unforeseen reasons, recently, Susie was unable to participate in this webinar, but as you can see, we still have a great group of panelists and experts to discuss design and its importance to the semiconductor industry. With that, I'll pass it along to Kevin.
Thank you, Robert. Share my screen here. I will just briefly ask for a virtual thumbs up to make sure folks can see this. Okay. You're getting stuck with my face all. Okay, so let me jump in again. Thanks again, Robert. As you said, my name is Kevin O'Buckley. I lead Marvell's custom chip design team and business. And to kick off my thoughts, I want to reiterate one of the key points that Ramiro made in his remarks. And that is today, companies based in the Americas do have a leading share of chip design in the global semiconductor industry. Whether you're talking about traditional general purpose processors designed by companies like AMD, where Mark is from, or Apple, artificial intelligence chips and machine learning chips from companies like NVIDIA or Google, or 5G data processing networking chips from my company, Marvell, all are leadership products, without question, the top of the industry. So our discussion today obviously is about how can we ensure it stays that way. And the reason that's important is that there is, from my perspective, a real tectonic shift that's happening in our industry. I think we all know as connectivity and compute continues to improve, we are making a decision as a society together to put chips into more and more and more applications to make things faster, make things move more efficiently, and make things run more effectively. Things that historically did not need a chip in them to function now do. And that's just a decision that we're making. That's driving demand for both chip manufacturing and design capabilities. I think we all know, all of us are working to ensure sustained access to world-class manufacturing capabilities. That's a clear and very appropriate priority in the CHIPS Act. But manufacturing and design, by necessity, are complementary and collaborative. And we'll talk about that today. My view very simply is that there is no sustained industry leadership that comes from excelling at either manufacturing or design at the expense of the other. Okay, so I promise not to spend too much time on sort of the high level stuff here, but from a semiconductor industry standpoint, I want to spend just a minute just sort of painting a picture. When you ask someone, "Hey, what's a chip?" They tend to think of something like this, right? Yeah, that's a chip. People jump right to that, but I think fundamentally chips are here. This is a chip. In fact, it's dozens of chips that happen to be connected to a screen, just like this. Dozens of chips connected to a screen. This is dozens of chips connected to antennas, enabling 5G radio communication. This 5 years ago was maybe a handful of chips on 4 rubber tires that were focused on, maybe making your entertainment system work, or making sure your brake sensors were functioning properly, or putting an idiot light on your dashboard saying, "Hey, change your oil." Today, a state-of-the-art car has hundreds and hundreds of chips and compute and networking capability that rival enterprise data centers from just a few years ago. All of the interconnected applications that we use today run on compute, storage, networking, security, all foundationally enabled by chips. And that extends also, as many of you know, to our infrastructure. The world of someone in a room with a knob that they turn to make more or less juice doesn't exist anymore. It's all electronically controlled, enabled by semiconductors. Same goes for water, at least in its most efficient and safest delivery formats. So what did I mean earlier when I said, I think of design as collaborative and complementary with manufacturing? I like to describe this using an analogy. I think many of you will see this as an imperfect analogy. I do too, but it's the best I've got. Another industry to consider that is the literal foundation, I think, of global infrastructure is real estate. Buildings, cities, picture our homes, but also our factories, office spaces, everything from strip malls to skyscrapers. All of these are designed and built. So we have incredible capability that we develop as a society for new materials, concrete, steel, glass, all construction methods that are enabled to put those together. But our end goal in infrastructure is not to make stacks of boards or piles of concrete. Right? We're creating spaces designed for safety and security, for worker productivity, efficiency and scale, for energy efficiency. So that is the domain of design. Our infrastructure leadership is really about both design and manufacturing. If you think of why reinforced concrete was even developed, right? It was developed because designers wanted to push buildings higher and increase the capacity of buildings. And so it goes for our semiconductor industry leadership. Our partners in manufacturing think in nanometers and angstroms, silicon processing materials and methods, the true state of the art for manufacturing globally in science and engineering. But our design teams think in terms of products and problems that need solving, new and evolving problems, things like self-driving cars, virtual reality, new methods for enabling data security or compute energy efficiency. So I know I'm sounding a bit like a broken record, but I just want to be really crisp on the point that manufacturing and our industry does not exist solely as either design or manufacturing. One without the other, at best is a half measure that risks both our prosperity and our security. So to look at just a high-level industry life cycle, Ramiro in his remarks had a nice sort of blow-in on the design sector, I think in 4 different segments that he showed. I want to just even maybe go a step further than that and sort of describe the design process, the importance of manufacturing, again, the focus of the CHIPS Act and a lot of our investments on sustained access to world-class manufacturing and fabs, and also acknowledge that even after the fabs, there's sort of a third leg of the stool, which is enabled by the packaging and the system OEMs, the true end customers for the semiconductor products that are designed and manufactured. When we think of design companies, I think many of us jump to fabless companies like Marvell, Qualcomm, AMD, NVIDIA. There are a number of them. And then in the fab and foundry manufacturing, pure play fab foundry companies like TSMC and Global Foundries are complemented by companies that live across both design and fabs, or IDMs like Samsung, Micron, and Intel. And of course, we have an incredibly important ecosystem of post-fab semiconductor manufacturing, packaging, both the substrate technologies as well as the assembly processes, the test processes, and of course, critically important are the end customers, the system OEMs. I described the collaboration that exists between design and manufacturing. That same collaboration is critical and exists between the system OEMs, the end customers that have demand and think of problems that need solutions, and the design companies that develop the products to solution those problems. Just some examples of the types of products that we're designing for infrastructure in the data center and compute and networking space. Many companies, including my own, are developing server processors or machine learning processors to compute data in non-traditional fashions. And of course, enabling all the data transfer for networking in the data centers. In the wireless infrastructure space, it's extraordinary the level of connectivity that we have now enabled by the most advanced 4G, 5G, and now beyond networking that are in development. And then, of course, in the enterprise space, moving data, securing data, and computing data is also equally important. All unique products that are developed to the requirements of system OEMs, either as a standard product or in many cases as a custom product to address a very specific niche application. So to wrap up my comments, I'll just offer 3 super high-level points from my perspective on the types of things that will be required or can play an important role in sustaining the leadership that we have today. When we talk about all this R&D intensity in semiconductor design, it's very important that we contrast that from the R&D intensity that happens in semiconductor manufacturing. In design, we are not buying multi-million-dollar lithography tools. We are not spending our capital on equipment. We're investing in people and talent and the software that enables that talent to utilize its time most efficiently. So what we are making an investment in with our R&D intensity is increasingly talented and increasingly large-scale design teams to make these products successful. The SIA and Boston Consulting Report opened my eyes a little bit on what R&D incentives look like globally. I think I would summarize my last 2 comments are, I woke up last year in a global market, and I hope that we stay in a global market, and that it means both access to global customers as well as access to competitive costs for our R&D teams, the people and the talent that we're investing in. And finally, again, my last skip on the broken record here, there is no advanced manufacturing capability, as a sustained advantage without advanced design and product capability to utilize it. So with that, I will thank you all for your time and pass it back over to Robert and I think Mark.
Okay, Robert.
Well, thank you, Kevin, for that really insightful presentation. I'm going to pass it along to Mark now. But before I start, I want to apologize to Mark. I asked him twice on how to properly pronounce his last name and still managed to mess it up. But Mark, go ahead, take care.
Yeah, Mark Fuselier. Yeah, hey, by the way, very happy to be here with you guys, and very happy to see a very important topic that we're discussing here with the SIA. And definitely, I think Ramiro and Kevin have both done a very nice job of setting up the key points that we're all aligned on. What I want to do is maybe zoom in a bit and share a specific example of the kinds of problems that the industry faces and why increasingly design and elements outside of manufacturing are becoming critical to solving those problems and showing the need for investment in design leadership. So I think we've probably all seen a chart like this before that just shows the energy production requirements that we have. If you look at over the next 30 years, the world's energy production requirements and just how increasingly computation is becoming a part of that. As Kevin mentioned, because of the trends around data generation, it really is driving an astronomical growth rate of the need for data collection and then computation to take, basically to take action on that data. So obviously we could all agree that this is a massive problem, that if we don't continue to scale power and cost, then the compute infrastructure is going to become a massive part of our overall power requirements. And I think this is a good way to frame the need for us to aggressively invest in people to help us find solutions to this. Now, making the problem even worse is, for many generations, we've relied on Moore's law scaling to really drive advances in power reduction. Increasingly, those advances are getting smaller and becoming much more spaced out in time. And so really, we aren't keeping pace with the traditional scaling that we've seen in the past. So, obviously, we're going to have to look for other solutions to make up the gap. In addition to that, the overall cost of delivering those scaling solutions with Moore's law is becoming more and more prohibitive. You can see here, just because of the challenges with lithography and the process in general, the timing between technology generations is increasing, and the cost per function, the cost of the generations is increasing as well. And so obviously we need new improvements, new ways to find solutions. And I'll just give you a couple of examples in the design space where we think that there are solutions to be had if we can invest heavily as an industry. So the first, I think many of us are familiar with chiplets. Very simply, by breaking up a design into individual components, smaller components, we can attack the cost problem. And many in the industry have already started to make this move. And as we look out in time, especially, I'm speaking from a lens of high performance compute, this trend will only accelerate. And so that's a solution, of course, that requires heavy design involvement in how we architect the solution and in packaging and how we put it all together. A second example here is with heterogeneous compute, application-specific compute. And so Kevin gave you some examples in the data center where the classic solution of just applying general purpose compute is not as efficient. And so many in the cloud business are looking at different ways to build specific compute devices that really drive better efficiency and better power performance solutions for their needs. And that, again, is a huge design problem. It's taking a problem that we used to solve with scaling technology generation and basically leveraging design innovation to deliver solutions. And that actually weighs also the need to build that solution relies on modularizing design in a way that puts more pressure on packaging. So I think the overall theme of having a solution that's not just delivered out of technology scaling, but also from design and packaging innovation is going to be key if we're going to solve this increasing problem of how do we scale power and costs. Now, as we've seen that those trends really take off, I wanted to share a couple of things with you in terms of how the tight integration between the manufacturing side of our industry and the design side of our industry, it's absolutely critical. And Kevin alluded to this in his comments as well. It really starts off with very, very tight collaboration in how we build system solutions, or do we have the right targets? And then how do we co-optimize the technology and design? All the way up in the architecture phase of both the technology generation as well as the design, there are very important decisions that have to be made collaboratively between manufacturer and design company to ensure that we've got the right solution that will optimize power performance and cost. Increasingly, building in architecture that accounts for advanced packaging is critical. And that is an important part of the design solution as well. And then, of course, as we begin to build the solution, increasingly we see continuous focus on how do we drive power and cost. So that may be in the design phase, even after the design, after the design is complete, there is continuous improvement in what can be done from both sides, the product side as well as the manufacturing side, to further improve power and cost. And then, of course, with any new technology, with any disruptive design solution, package solution, or fab solution, it's critical that we work together on risk mitigation. And so this just gives you an insight into, from an AMD perspective, our approach to bringing together the critical parties in this ecosystem, from manufacturing through the design ecosystem, and ensuring that we have a common and well thought through solution. So with that, I'll hand it back over to Robert.
Thank you so much, Mark. So now we're going to move on to the Q&A phase of the webinar, and we have a bunch of questions now. And I just want to start off on a point that was raised in the design report, but also Kevin mentioned in his presentation, and that's the rising cost of design. And really, both for you, Kevin and Mark, could you just briefly touch on how the rising cost of design is affecting your company's ability to maintain competitiveness domestically and globally, and what do the rising costs really mean for the U.S. semiconductor industry?
I just briefly, Mark shared some fantastic examples of some of the technical innovation that's going into trying and servicing a broad variety of demands with the increasing costs of investing to support each of them. I think one of the biggest challenges we have, as I think of the global semiconductor industry, is with expenses going up. I mean, that was an extraordinary chart, which showed us going from tens of millions to hundreds of millions of dollars of expense over just the last few generations of product, and that's very, very real data. The biggest challenge we'll have long term is you need revenue growth to keep track with that type of expense growth. Just very simple. It's not a semiconductor thing. That's a very simple business statement. And shrinking the market, for example, if we bifurcate the industry, or if we have less access to global demand for our semiconductor products, that can really radically disrupt the challenge of making these investments if we don't have confidence that we can actually supply parts to our customers.
Yeah, and well said, Kevin. I would just add also that it will, I think the other side effect is it slows the pace of innovation, which is just what we don't need. And it does that by, number one, obviously, from a financial standpoint, you can only fund so many projects given the cost of designing, increasing cost of design. And the other element of it is it will have the effect of, over time, shrinking the pool of companies that can afford to invest in design. And of course, that affects competition. So in the long run, I think the danger here is that important scaling and the pace at which our industry needs to innovate to solve all of these challenges we've talked about will slow down. And that's not something that any of us want to see happen.
Mark, I love that point. I'll just compliment the antidote to that. I'll say, if we have the R&D dollars to spend to solve these problems, you need the people too, right? I mean, the investment, we really need the talent in order to make the investments to solve the problem. So it's a very, very circular problem.
Right. Kevin, thank you, because you've basically helped segue to the next question, and that's the challenge of finding, talent within the industry, right? There's a current talent shortage that's affecting, many different industries, but it's pretty acute in the semiconductor industry. So, I'm wondering, how is each of your companies working to sort of mitigate the risk of the talent shortage, and building that pipeline between students and the industry, or workers that are seeking to join the semiconductor industry? What sort of workforce development programs are your companies implementing to mitigate the risk of the talent shortage?
Yeah, I can speak from our side. Definitely investment in STEM, and trying to funnel more folks into STEM-based fields is critical. And so that is a big focus for us in both, in our contributions from a dollar standpoint, but also our volunteerism is really focused on how can we reach out into the community and work with universities to try to steer more, more future workers into STEM fields and specifically into semiconductor design. That I think as an industry is something we need to find a way to motivate more kids, that have increasingly been looking at software. How do we get them back into semiconductor and make it sort of the place that people want to go to chase technology as an industry?
Yeah, and Kevin, I don't know if you want to chime
No,
in.
I totally agree. Sorry, I hand-handed the mute button there and disconnected myself for a second. I apologize. I think Mark's comments are obviously right on. I just at the highest level, my personal reflection is clearly not enough. Whatever it is we're doing, it's the right things, but it's not enough. As I reflect on just the last couple of years, if I could take the supply chain problems and just sort of put them in a box and set them aside, the number one thing that has been our management priority has been talent acquisition. And unfortunately, the most successful lever we've been able to pull is acquiring other companies. That has been our vehicle to get more talent. And that's a zero-sum game for the industry, right? I mean, all we're doing is sort of moving people around in that. So that's not a sustainable long-term solution, even though it's been the number one solution that we've been successful at over the last couple of years, and it's not easy. So the things that Mark was describing, true talent development, partnerships with universities is critical. Some personal beliefs. I mean, I really think as an industry and as a society, as we push chip semiconductors into the foundations of our infrastructure, we got to do something to make it more attractive for people to go into hardware and software engineering to support this. I don't know if it's free tuition for certain. We've done things like this as a country and an industry in the past, and I think we're nearing the point where we have to do things like that. Again, that's a personal view.
So, sort of along the same lines, you mentioned the challenge of just visibility of the opportunities in the industry. What if you could name sort of the top 2 or 3 challenges in the talent shortage of gaining talent? What would those be? What would the top 3 challenges be?
I mean, marketing is, this is a silly answer, but making this something that people want to do is a huge problem. And I have this discussion with my kids. I think all of us see this, right? What do they want to do? They want to, the interface for technology for people in my generation 20, 30 years ago was tinkering with stuff, right? You'd play with hardware and you'd build it up. The interface for technology now is software, right? People have devices and they want to interact and use those devices. And they want to be YouTube stars, and they want to sort of apply social technology. So we truly have to do something as an industry to ensure that the importance of the hardware and the underlying software at the hardware level is an attractive thing for people to want to invest their time and interest in.
Yeah, well said, Kevin. And I would say, there are a few things also that maybe that we should look at. Clearly, immigration policy is one area where we definitely can benefit from having skilled labor that is able to work in the U.S. Another is retraining. So there are a lot of folks sort of on the tangent of doing design work that could be trained and brought into design roles in the industry or in the science field, that I think is a good opportunity too. And another key focus should be on diversity. I think a lot of, in terms of attracting talent into the industry, I think we have a huge opportunity as an industry to correct a lot of by having more diversity, we can actually bring more folks into the field and contributing at a high level. I think that's key for us to solve here as well.
Great. That's an excellent point, Mark. I'm just shifting gears a little bit. I'm wondering if you can each speak on sort of in more detail, the collaboration that your companies have with, the foundries and packaging companies and OEMs to design the chips, making sure that the chips that you design meet the specifications of your customers, that manufacturers are able to actually produce the chip that your company's designed with the correct raw materials, and other inputs. And I don't know, Mark, if you want to start off.
Sure. Yeah, I mean, it's fundamental. I think the way to think about it is with the amount we it's well known how much the size of the bets that are made on manufacturing capacity. The other thing that's maybe not as appreciated is the time scale. It really is a 4 to 5 year bet that we're as an industry making, both in terms of the manufacturing capacity and the design. And so those bets have to pay off. And so it's very much in the manufacturer's best interest that they're working with the design company to make sure that the solution that we're providing is going to be a winner, because that volume is critical to be able to drive reinvestment. And so it's a very, very collaborative, close engagement where they're increasingly understanding the types of problems we're trying to solve for our customers and looking for ways to work hand in hand to find those solutions.
Totally agreed. Just to add a little flavor on sort of the system OEM into the design house collaboration to complement the manufacturing perspective. There's been extraordinary consolidation in our industry on the number of customers, the world of 900 different white box companies making things, and has been consolidated to count them on your fingers hyperscale customers, and count them on your other hand fingers major PC companies and server companies. So those big bets that Mark just described are actually even bigger, because not only is the investment we're making, but if you miss one of those fingers, it can be catastrophic. So I think just the fundamentals of those partnership and entering years in advance to the general availability of a product to make sure you're completely aligned with your end customer on not just the specs, but the details of the use cases and software requirements, so that you're really developing the product that X years from now will be still the product that's required to solution this need. It's massive.
Right. And so I guess to give it a bit more flavor, let's think about the automotive industry, right? Not too long ago, a typical car would have, a couple hundred chips in it. Now, the most advanced cars have thousands of chips in it. And so can you just discuss sort of how, from the designing of the chips that go into a Tesla or any of the, driverless vehicles, what was the process and what was the end result, and how is it still maintaining innovation within the industry?
Yeah, the automotive space is super interesting because it's sort of done like a step function in terms of the sophistication that industry is approaching semiconductors, because of exactly the dynamic that you described, Robert. I mean, 5 years ago, there were a handful of what are called tier ones, companies like Bosch and Conti and others, Denso, that really were sort of the points of control and interest in, hey, what semiconductors are required? They would develop a platform, and that platform would either service the major car manufacturers and OEMs or not. What's happening now is the auto manufacturers themselves, frankly, seeing Tesla as maybe the leading example of this, are saying, look, we have to take control of the specifics of the semiconductors that are used in our products in order to make sure we've got a differentiated product that doesn't have capability that someone else has. They can't just count on, X tier ones to develop something that everyone will just use. And that's a big dynamic shift in the industry. It means we're getting much closer with sort of tier one car companies, rather than sort of living in this, with the OEMs themselves, rather than living in sort of the supplier base. Big change.
I don't know, Mark, if you want to add anything to that, but it's not just the automotive industry. We have it in quantum computing as well, and advances in AI. one of the ways that design companies are able to continue to innovate is that close collaboration with packaging. We talk about the end of Moore's law, the potential end of Moore's law. How are design companies, overcoming that? And Mark, if you want to.
Yeah, and I think, definitely, as you mentioned, packaging, it's a big component of how we continue to extend scaling. And so, it is, by the way, in many cases, it involves the same manufacturers, right? The foundries are in many cases developing these capabilities because the lines are getting blurred between what's a fab technology and what's a packaging technology. So, they are able to see sort of what's required and develop those capabilities. But in some cases, it's different manufacturers. So I definitely, our sincere hope is that we will continue to find ways to extend the process technology, scaling, albeit at a slower pace. We still need continued improvement. We think that, or from what we see, a lot of the things that classically have been done, just lithography scaling, are probably not going to get us there, but there are ways with maybe features or different ways of building transistors that will give us scaling, and that will be important to build in. But in all of that, we're going to need solutions that require things like advanced packaging. In the system space, we'll need new techniques for how we handle more power. And in the design space, how do we build heterogeneous solutions? How do we sort of break the design up into chiplets and bring them together? So I think, the way we solve this is really across the ecosystem. We're going to have to eke out improvements and really make sure that we're bringing them together really, really well in the system at the end in the system environment.
And so we got one question from an audience member, and I guess this is more directed to you, Ramiro. Could you just sort of discuss some of the methodology behind, the loss in U.S. share versus, the rise in other countries in terms of the design capabilities?
Yeah, makes sense. So the obviously the historical, from an analytical perspective, the historical stuff is just an empirical observation. So it's just the trend and it is what it is. Going forward, what we did was we looked at the patterns in the labor and the workforce, so effectively where design work was being performed. And we also effectively made the assumption that the most critical design work is typically going to be performed in the headquarter country of a given company. So with those two assumptions, effectively, we kind of modeled out, what does the workforce look like based on immigration patterns, domestic training patterns by region, retirement, attrition patterns, et cetera. And that's effectively how we forecast on a go-forward basis.
Great. Excellent. One more issue that was brought up in the design report was the pressure on access to global markets. As we continue to see sort of the growing political tensions, geopolitical tensions, the effects of the pandemic, and sort of policies that have become restrictive for global markets. How do you see this affecting, the ability of design companies to continue to innovate and really, maintain their ability to gain talent, to mitigate the rising cost? Can you just discuss how, the access to, or the pressure on access to global markets is affecting the design companies?
And Robert, yeah, Mark, do you want to? I'll let Mark and Kevin go first.
Yeah, I think, all of the things you mentioned, Robert, I think, open markets, to the point Kevin made, it really opens up the revenue aperture that's important if we're going to keep investing. Anything that we do that really limits the abilities to, build revenue bases or, access talent from around the world is really going to hinder our ability to solve these really challenging problems. So, from my perspective, the more we can do to motivate, more open and collaborative dialogue, the better for our industry.
Completely aligned. It's that demand and growth that has driven the innovation, right? It's a virtuous circle in that case of investment, chasing the demand that's out there. I do want to just very, very briefly, I saw another comment associated with this. I used the phrase bifurcation earlier, and I think I may have used it imprecisely or created some confusion. I was referring specifically to this, the concern that, less access to a global market creates bifurcation of everything from standards to revenue to and on and on and on to talent access. That's what I was referring to.
And I don't know, Ramiro, if you want to chime in as well.
Yeah, I mean, the only thing I would add, and again to Mark and Kevin's point, if given the R&D intensity and the costs that we talked about to design new chips, if you cut the overall market in half or cut the overall market in thirds or whatever it is, you end up with smaller subscale ponds, which either mean which basically slow the rate of innovation, because you have to be able to amortize those costs, and you may not be able to justify specific projects if there's not a global market just based on those kinds of things. So nothing incremental to add, but just to build on those 2 points.
Right. And it all leads to the rising cost, right? And making sure that companies are able to mitigate those costs to continue to innovate. I'm wondering, when we look to the future, right, 5-10 years from now, with continuing advancement in chip design, what do you each see as sort of the next, technology breakthrough, right? Is it 6 or 7G or new improvements in AI? What sort of, revolutionary, technology do you see, coming forth in the next 5 to 10 years based on innovation in chip design?
Yeah, I mean, I just at a high level, I think that the transformation of computing from a traditional load store architecture where we're sort of programmatically describing how a software needs to run to the world of machine learning is frankly happening faster than I think I or many had anticipated. And the application and the workloads that machine learning can actually address, I think, is much broader than had originally been anticipated, at least by some in the industry. So I think that's a huge pivot in what computing needs to look like, and that has everything from what does a processor look like to where does the memory need to be to who's designing the software and what does the data look like. So that's a massive one. A little closer to home, Robert, the only other thing I would mention is aligned to Mark's comments, and we do need to make some real fundamental changes in the transistor architecture itself, to reduce some of the scaling challenges that we have, and package and associated cooling technologies is without question, belongs on a list of the 3 big industry transformers right now, from my perspective.
Yeah, and I completely agree. I think Kevin's hit the big ones. The one I would add also, there's another challenge with just moving data around the data center. And we have a huge opportunity to save power with optical and photonics. It's a big challenge in how to deploy, but I think in that time frame that you mentioned, 5 to 10 years, it's a big opportunity for the industry to really. It's sort of, you can think of it, a frictional tax on power, and if we can innovate in a way that makes that more mainstream in the data center, that's a huge opportunity.
Excellent. I think these are all, great opportunities for the U.S. to maintain its leadership, right? If design companies are able to maintain, innovation, these are things that will revolutionize technology, revolutionize, data transformation, clean energy, greater infrastructure in major cities. I think, it all starts with design, right? there's no manufacturing if there isn't a chip that's been designed by your companies at, the specifications of your companies, and ensuring that those chips are able to be designed with, breakthroughs in raw materials and metrology. So I think all of these are important points to make, and why design is so important to the semiconductor ecosystem and manufacturing. Really, you can't have manufacturing without chip design. With the last 5 minutes, I'm wondering if there are any final thoughts that you, Kevin or Mark, would like to leave with the audience about chip design that you think are important.
I think actually I look back at how Kevin opened. I thought it was those points that he ended with in his presentation, I think were right on. So I think investing in building the talent base, we have to continue to invest in the talent and the people. And we have to remember that, as he said, the ecosystem requires that we not be biased towards manufacturing only or design only. It takes investment in both. And so I think it's critical that that as an industry and as a society that we're looking at ways to do those things.
Totally concur. And I think it's great that we have a forum like this to discuss it. So much appreciated.
Well, thank you again, Mark and Kevin and Ramiro, for participating in this panel. I think it was very important issue to discuss. As you said, Mark, you can't have one without the other, right? It's a investment in both, so that the U.S. leadership in semiconductor industry is maintained. Just as a reminder, the presentations will be available on the SIA website in the next day or so. You can also view the SIA BCG design report on the SIA website. It is a free report, and I would highly recommend everyone read the report to get a better understanding of design and its importance to the semiconductor ecosystem. And with that, I'd like to thank Mark, Ramiro, and Kevin again for participating in this webinar. And that concludes this presentation. Thank you, everyone.
Hey, thank you.
Take care.
Take care.